Here is another integral where the method substitution ends up working, but it requires a little bit of work because what we may want to try first ends up not working. Okay. So what are the inside candidates? Well, one thing we could try is the whole inside of the denominator. We've seen that before, that you can use the denominator as an inside of something while it's inside the denominator. So we can let u equals 1 plus x to the 8th. I would like you to try that, even though I can tell you right now it's not going to work. Okay, but I want you to try it. Again, at this stage, it's very important for you to try any substitution that you think is reasonable, even if it doesn't work, because if it doesn't work, I will just tell you why and will give you some experience about why it is not working. The next thing you may want to try is say, okay, how about just x to the 8th? That looks like a little bit simpler. It's another option. It's inside a sum, which is inside the denominator. It might work. Not really. Ditto. Does not work. Okay, you can, but again, you might want to try and see why it doesn't work. So what works? Well, here what works is a little bit of experience. What you can do is what we are going to do is we're going to focus not so much on the x to the 8th, but the x cubed, which is on top. And we're going to notice that x cubed, well, apart from the coefficient, is really the derivative of x to the 4th. And I can write that x to the 8th in the bottom as x to the 4th cubed. What did I say? Cubed. X to the 4th squared. The cube is on the top. Don't confuse the two. All right. So what we're going to do is we're going to look at that x to the 4th as the basis for our change of variable. So we're going to try u equal x to the 4th. All right. So let's try that. If I try u equals x to the 4th, then its differential is 4x cubed dx, which means that dx is going to be equal to du over 4x cubed. And you can tell already that we'll be canceling those x cubed. So let's make the substitution. Our old integral will become the integral of x cubed, well, stays x cubed. By the way, as you move on, you may be able to skip some of these steps and see ahead of time what kind of cancellations can be obtained. By all means, do it once you feel ready to do it, but do it safely. Okay? Otherwise, keep doing it the slow way. So we have x cubed stays as x cubed. The denominator now becomes 1 plus u squared, and then the dx has become du over x cubed. Well, the x cubed now cancel, the 1/4 can go outside, and we're just left with this one. And that's obviously a very easy integral. It's not? Don't tell me you've forgotten that integration formula already. Well, think about it backwards from some familiar differentiation formula. Remember? No, go and look it up. Done? Okay, so you now know, you remember that that was actually the derivative of inverse tangent. So that integral is just 1/4 inverse tangent of u. Of course, we're not done yet, not only because I didn't mention the plus c, but I did write it down, so make sure it's always there, but also because we have to get back to our original variable, which remember was x, and we do that by changing the u to an x to the 4th, and we're done. Once again, you may want to check that this is correct by taking the derivative of this particular function and make sure that it is what we started with.